All right, you've got a chance to practice, so now let's look over these. You saw the answers in the back of the book, and so these weren't too difficult. Hopefully you got them all right. I'm going to go through them pretty quickly right now. On number 21, you've got this airplane. It's flown 3 degrees off course, okay? So the question part is, which one am I looking for? Am I looking for, or did the plane fly, and is this the 135, or is the hypotenuse the 135? And hopefully everybody realized that it was the hypotenuse, because that's the actual flight that it took. And so now it's some, I'm going to put E for error, it's some small distance off course. Now it gives us to the nearest tenth of a degree, and then it gives us 3 sig figs right here. And so that does point to an answer of 3 sig figs. So we know that the sine of 3 degrees is equal to the error over 135. Multiply both sides by 135. You get that the error is 135 times the sine of 3 degrees, which gives you an answer of about 7.07. So what does that mean? It means the airplane's about 7.07 miles off course where it's supposed to be after only flying 135 miles. If you're 7 miles from where you're supposed to be, that's kind of a problem. It can't land. All right, let's look at number 23. Number 23 gets back into some problems very similar to what we had done. It says a bullet's fired into the air with initial velocity of 1,200 feet per second. Notice that's 2 sig figs, an angle of 45 degrees, again pointing towards 2 sig figs, from the horizontal. Find the magnitude of the horizontal and vertical components of the vector. Now, this, we can really do no trig on this one because we could draw and set up a 45, 45, 90. Excuse me. And it could look like that. And we know that this is 1,200 feet per second. And so then this side is going to be 1,200 divided by the square root of 2. And this side is going to be 1,200 divided by the square root of 2. Now, you could have also used trig. You could have said, well, you know, the sine of 45 degrees is equal to the vertical component over 1,200 and multiplying. You could have said the cosine of 45 degrees is equal to the horizontal component over 1,200. And you know, and that would have come out to be the same thing. But also, if you know your 45, 45, 90s, you can just do that. So you go 1,200 divided by the square root of 2, and that gives me 848.528 such. And so what is that? Well, that's about 850 feet per second. Okay, and because this is a 45, 45, 90, this one's going to be the same. I put it in 2 sig figs. That's how I got 850. All right, number 25. Number 25 says distance traveled by a bullet. Use the results in problem 23 to find the horizontal distance traveled by the bullet in 3 seconds. Because remember, this was feet per second. Well, super easy question. All you had to do is go, well, 850 times 3 seconds, which would give you what? 2,550 feet. Okay, 2,550 feet. I'm going to make sure that as I'm doing these, my answers correlate with what's in the back. Yeah. Okay. All right. Next, 27. Okay, a ship travels 130 kilometers on a bearing of south 42 degrees east. How far east and how far south has it traveled? Well, remember, bearing is always measured off the north-south. So to say south 42 degrees east, that means it's somewhere about here. Okay, there we go. And this would be 42 degrees. It's always measured off the north-south. Okay, it says the ship traveled how far? 130 kilometers. So everything's pointing towards 2 sig figs. We have 2 sig figs right here. We have to the nearest degree, so it's pointing towards 2 sig figs. And so the question is how far east and how far south has it traveled? And so those are the 2 things we have. We have, okay, how far east has it gone and how far south has it gone? All right, so I know that the south could also be right here, and I know that this angle right here would be 42 degrees. I could also figure out that this angle right here is 48 degrees. I know this is the right angle. So all sorts of stuff you can figure out that you should already know. So we're using the hypotenuse because the hypotenuse is the 130. So I can say that the sine of 48 degrees, notice I'm looking at it from this perspective right there, is equal to opposite, which is how far south, over hypotenuse, 130. So therefore, how far south is equal to 130 times the sine of 48 degrees. All right. What else? So then plug it in my calculator, 130 times the sine of 48. And I get that that's about 97 kilometers. Okay. Let's see here. And then if I'm going to do, I could go ahead and use 42 degrees. I'm just in that position where I'm using that 48 degrees. So I'm going to say cosine of 48 degrees is equal to adjacent, which would be how far east over that 130. So again, how far east is going to be 130 times the cosine of 48 degrees times cosine of 48. And that is, I get, in terms of 2 sig figs, 87 kilometers. And that is what they have. Oh, I'm sorry, I'm on the wrong page. Golly. 9787. That's what we got. Okay. All right, let's talk about number 29. 29 says the velocity of an arrow. Now, we did one almost exactly like this. It says an arrow shot, so its horizontal velocity is 35.0. Notice 3 sig figs. Okay, 35.0 feet per second. The vertical is 15.0 feet per second. So this is the horizontal and this is the vertical. And it says find the velocity of the arrow. Man, I hope you realize that this was super easy because all this is Pythagorean theorem. There's no trig on this one. Okay, it's 35.0 here, it's 15.0 here. We want to know what the velocity is. So 35 squared plus 15 squared. And you're going to get 15 squared plus 35 squared is going to give me that velocity squared, which ends up giving me 1450 is equal to velocity squared. So therefore, the velocity equal to the square root of 1450, which is about, in terms of 3 sig figs, would be about 38.1 feet per second. And we double check that. And yes, we feel good about 38 point. Now the funny thing is it also asks, because it asks for the velocity. All right, so now you probably saw in the back of the book that it had the angle right here. You may go, why in the world did it give me the angle? It didn't ask for it. Well, because velocity is always direction and speed. It's not both. I'm sorry, it is both. Speed is just how fast something's going. Velocity refers to how fast something's going, but also which way is it going. And so it was really kind of also looking for this angle. So I could say, well, I know the tangent of theta is going to be equal to 15 over 35. So therefore, theta is going to be equal to the inverse tangent of 15 over 35. And so we go 15 divided by 35, boom. And so we get that the angle should be 23.2 degrees, about there. Okay, 3.2 degrees. All right. Okay, home stretch, number 31. Number 31 says a plane travels. Now this is probably going to sound a lot like problems we had done before, but it is definitely a little bit different. It's not the same as the ones we saw in the previous chapter or previous section. It says the plane travels 170 on a bearing of north 18 degrees east. Okay, so I'm going to draw that like, oof, that was a rough line. That was even worse. There we go. That'll work. So we're going to say that that is 170 miles. And what we know is that this angle right here is what? 18 degrees. Because it's 18 degrees east of north. And then at that point, it changes directions. And now it's going a little bit more east. It's going more like, and it's going 120 miles, so a little bit shorter. Okay, so we got 120 miles. And at this point, this angle inside here is now 49 degrees. Now notice, we don't have a right triangle. So we could connect these right here, and we don't have a right triangle. So that would lead me to believe it's probably not a great idea to connect these and think that that's where I'm finding everything. This is a pretty big problem, because really what we have is we've got to look at this first flight and go how far east and how far north did that one go. So I'm going to call that like east 1 and north 1. And then the second part, how far east and how far north did they go? So I'll call that east 2 and north 2. And what it's asking for 31 is it says, well, find the total distance traveled north. So it wants the total n, which would be equal to, in my problem, n sub 1 plus n sub 2. And it wants the total east, which would be east, would be equal to e sub 1 plus e sub 2. All right? And so that's what we're looking for. So this problem's got a lot going on. Now realize if that outer angle is 18 degrees, then this inside one right here is 72 degrees. And if that outer one is 49, then this inside one would be 41 degrees. And so what I can do is I can say, well, I'm going to just focus on north first. Okay, so in this first triangle, I know that the sine of 72 degrees is going to be my north 1 over that 170. So therefore, north 1 is equal to 170 times the sine of 72 degrees. And then in the second triangle, I know that sine of 41 degrees is going to be equal to north 2 over 120. So therefore, north 2 is equal to 120 times the sine of 41 degrees. So therefore, the total distance north is equal to, because we know it's equal to north 1 plus north 2, is equal to 170 times the sine of 72 degrees plus 120 times the sine of 41 degrees. And plug that all into my calculator at 1 time. So that way I'm getting the most precise answer the calculator can give me. Plus 120 times the sine of 41 degrees, close parentheses. And I get that north is about, now everything was in 2 sig figs, right? Everything was pointing towards 2 sig figs, nearest degree, stuff like that. And it is. It comes out to 240 miles is how far north they traveled. Okay, so then to do for east, it's the exact same problem, but of course this time I'm going to use cosine. I know that the cosine of 72 degrees is equal to how far, my E1 over 170, and the cosine of 41 degrees is equal to my E2 over 120. And I go ahead and multiply both sides, so therefore I know that E sub 1 is equal to 170 times the sine of 72 degrees. E sub 2 is equal to 120 times the cosine. I said sine, didn't I? My bad. Cosine of 41 degrees. And so therefore my total distance east, because that's the sum of E sub 1 and E sub 2, is the combination of these. 170 times the cosine of 72 plus 120 times the cosine of 41. So plug that all in. 170 times the cosine of 72, close the parentheses, plus 120 times the cosine of times the cosine of 41, close parentheses. And when you put that all together, I get that it's about 143.098, but everything's pointing towards 2 sig figs. So I actually have to round that down all the way to 140, okay? And so there's my 2 answers. How far north did they go? About 240. How far east did they go? About 140. Okay, hopefully this made those problems make sense if they didn't already, and now you can try the rest. We'll talk to you later.